and by the way, have everything organized tomorrow. I got these kids that were gone on Friday to get caught up. Have everything organized and ready to go tomorrow for 6.1. I would encourage you, if you have questions, 6.1. We might have time at the end of the hour to talk here a little bit. But guys, we talked in the last section about inverse variation and direct variation. Okay? Inverse variation and direct variation. What was the formula for inverse variation? Or the form, if you will? A over X. And A was some number other than? Okay, and then what was your direct variation form? Okay, now we didn't talk much about the graph of inverse variation, but what we're going to get into is this. Inverse variation takes on this type of graph. In the first quadrant, as X increases, your Y value might decrease, or it could do something like this, or it could do something like this, or it could do something like this. Okay? Those are the types of graphs that you're going to see for inverse variation. And inverse variation is really related to what we're going to look at today in 6.2 called graphing. What's the word? Rational functions. I always tell kids, you hear the word rational, think what? Think fractions. Think fractions. Isn't inverse variation in fraction form right here when I look at y equal a over x? Okay. So what we're looking at today, guys, is graphing rational functions. And the question I want to answer today is, what are some of the characteristics of the graph of what types of functions? Well, rational function. So our goals. Volunteer to read the first one.
Graph simple rational functions.
Graph simple rational functions. This is going to be pretty easy, okay? Second one. Translate simple rational functions. Then we're going to graph other rational functions. Decimals is going to be key for you today, all right? Make sure you have it available to you. All right, here we go. Rational function has the form f of x equals what over what, kids? P of x over? Where P of x and Q of x are what? And Q of x does not equal what? You don't want what in the denominator? Can't have 0 in the denominator. The inverse variation function we just got done talking about. It's like y is equal to a over what? This is called a. Okay, let me give you a form of a rational function or an example. If a rational function, what we're going to kind of see, might look like this. F of x might look like, I don't know, how about 8x minus 6 over 2x plus 4. Okay, you've got a polynomial up from top, 8x minus 6. On the bottom, you have a polynomial, 2x plus 4. Now, most of the polynomials that we're going to look at for these rational functions, the polynomial in the numerator denominator, most of them are going to be to the first degree. We'll get more complex as we move through the chapter, but for now, most of the stuff, first degree. Domain, don't forget, domain is what? Okay, domain is the x value or the inputs, okay? Is there anything I can't put in there? And what we're going to start looking, or what we're going to start finding out with domain, kids, is this. We're going to say that domain for a lot of these is going to be all reals, but I want to make a reminder about domain. We got to find x so that the denominator, we never want the denominator to be what? We want the denominator so it can't equal 0. Guys, think about this right here. Look at this function that I wrote up top. If I didn't want 0 down here, what number times 2 plus 4 would make 0 in the end? In other words, 2 times x plus 4 is equal to 0. What would the x value be to make the denominator 0? Negative 2. If I plug negative 2 in there, we're making the denominator 0, wouldn't it? 2 times negative 2 plus 4. So we would say the domain on that function up top there is all real numbers except for negative 2. And we're going to look at stuff like that, okay? All right, then the range is just simply what, kids? The y values or the outputs, okay? One of my favorite words, and I don't know why. I think it's kind of funny. Asymptote. You guys heard the word asymptote before? What's an asymptote? Have I done the old, if I start right here and walk halfway?
Yeah.
And then go from that point halfway again? and then go halfway again, and halfway again. Will I ever get to that wall? No, that wall is like the asymptote. I will get so close to it, but I will never ever get there because I keep getting closer and closer. So an asymptote is like a line that continually approaches a given curve, but does not what? Okay, so we're saying, well, this line, like I'm just drawing right here, this line is going to keep getting closer and closer and closer to the x-axis, but is it ever going to cross? Okay, what they call that is like a limiting parallel. Okay, there's a limiting parallel there. Goes on forever, and the limit here is 0, but this line never touches it. Okay? All right, if I had to draw this visually then, you might have something like this. Here's your coordinate plane. You might have a graph that does this. I don't know. There might be a dotted line up here like so. We're saying that curve is never going to cross that dotted line. That dotted line is your asymptote. And that's not the greatest drawing in the world, but here's a curve here. It's going to keep on going forever. Is it ever going to cross the dotted line when they put that dotted line in there like that, kids? No. And that's your asymptote. And then long division. You guys are going to get frustrated today. Well, you're not going to get frustrated. You're just going to have to do a little bit of... Sometimes they say when you want to clean something, you got to put a little elbow grease into it, right? You ever heard that? What the heck is elbow grease? Manual labor? Is that what they mean? Okay. You guys, I want to make sure you high up people, so understand how to do this, okay? You want to be the people telling other people to do the work with elbow grease, okay? Be the ones at top. All right. Long division is a way to find the quotient of the dividend and the divisor. We'll talk about that. You know what long division is. But we're going to be looking at long division like this, like x plus 6 divided by maybe x plus 2. Stuff like that. Okay? Make sense? And I'll show you how to do that again. We're going to remember how to do that. You guys remember synthetic division? Okay, we might have lost the process a little bit, but we might revisit that a little bit today, okay? All right. First page terms. Are you okay with them? All right, let's talk, kids. Page 2. So on page 2, core concept. Here's a core concept. All right. What I've put up here is a parent function for what, kids? Okay, it says the graph of the parent function is f of x equals what?
1.
Okay, if you would put this function right here, if you would put this function right here in decimals, whoa! I see a big blue swimming pool person. Okay, what I've graphed here is that function f of x equals 1 over x. That's the graph. So real quickly, kids, just how do we get this? Guys, what's 1 divided by 1 when I put this in here? 1. Okay, 1 shows up. Okay, what if I put in 2 down here? If I plug 2 in, what you going to get out? 1/2, then 1/3, 1/4, 1/5, 1/6. We get all the way over there to like a trillion. You're going to have 1 trillionth, right? Is 1 trillionth going to cross 0 or be just a little bit above it? So are there asymptotes to this graph? Absolutely. It says the function 1 over x is called a, what's the word I'm highlighting right here? Hyperbola. Okay? Parabola, hyperbola. What you've got out here is a graph. It's called a hyperbola. Now sometimes, kids, if I would put a negative up here from the first and third quadrant, that would flip it to the first and the... second and the fourth quadrant. Yep. Okay, it consists of 2 symmetrical parts called, what are these called? Okay, so this part right here is a branch. This graph is a branch. The domain and range are what? Okay, what do you have here? What is the x-axis really going to be here for us, kids? If I said, hey, the x-axis right here, do your branches ever cross the x-axis, kids? No. So the x-axis would be considered an asymptote. Let me ask you this question. Are these branches ever going to cross the y-axis? No. So this would be considered what, kids? An asymptote. By the way, what's the x value right here, kids? If I threw 0 in here, would that work? X can be any number in this example except for what? Okay. Now here's the parent function, and this is just the graph for 1 over what? Okay. Now, what we're going to look at here is this. It says the domain and range are all non-zero real numbers. It says any function in the form g of x equals a over x, where a does not equal 0, has the same what? Asymptotes and range. So if I change 1 to 14, the domain and range is still going to be all values except for 0. If I change this to 22, domain and range, what is it? All values except for. If I change this to negative 99, the domain is everything except. Okay, now we're going to start looking at how do we transition stuff here. So right down here, it says graphing a rational function of the form y equals what, kids? Okay, it's pretty simple. It's pretty simple. You're going to have the same shape, but what I like to tell kids is figure out your curve. Okay, and then it says compare that to the graph of 1 over x. So what are we graphing here, kids? Y equals 6 over x. Is that what we're graphing, kids? Okay, help me plug some points in. Okay, can I plug 0 in? Can I plug 6 in? Can I plug 1 in here? If I plug 1 in, what's your y value? So I'm going to graph that. If I plugged 1 in, 6 would be this right here. Okay. How about I plug 2 in? What are you going to have? 2 would be, what's 6 divided by 2 when I plug that in over here? What's 6 divided by 3? 3, 2. How about 6 divided by 4? 1.5. 6 divided by 5 would be about 1.2. What's 6 divided by 6 here?
1.
Notice how 1, 6, and 6, 1 were graphed there. Did you see that? 1, 6, and 6, 1. See how they're graphed there? Okay. Now I'm just going to sketch this right here. This would be a pretty good sketch of the graph through those points. And eventually this is going to start to do what, kids? Okay, let's put negative numbers in there. What's 6 divided by negative 1, kids? Negative 6. What's 6 divided by negative 2? What's 6 divided by the x value of negative 3? So come down to negative 2. 6 divided by negative 4 would be negative 1.5. Negative 1.2. What's 6 divided by negative 6 going to be, kids? You see your curve forming there for the hyperbola? Okay, now I want to talk about this. How does that compare if I read the directions, and I'm going to graph both of them in decimals? How does that compare, kids? How does that compare to the graph of f of x equals 1 over x? Okay, all we did was plug points in. Let me get to decimals here quickly. La, la, la. Good job, guys. Okay, what was it? 6 over x and 1 over x. Was that right, kids? We need to compare 6 over x to 1 over x. I'm going to put the parent function in because what's the parent function again first, kids? 1 over what? There's your hyperbola, right? We just graphed not 1 over x, but 6 over x. Okay, the question becomes, how does that compare? Whoa, Parson, you screwed it up. Yee-haw. How does that compare, kids? Same kind of shape? Did that 6 pull the branches away from the origin or push them towards the origin?
Away.
pull them away. So what I would say is this. Gosh, guys, isn't that 6 over x kind of like this right here? Isn't it kind of like, listen to what I say. Isn't this like 6 times 1 over x? 6 times the whole function 1 over x. When you throw a 6 out in front of a function, what kind of effect does that have when you transform stuff?
No, stretches.
Stretches it how?
4 by 6.
Okay, you could say one of two things. It pulls the branches away from the origin, or you can say there's a vertical stretch to the function. Okay? Does that make sense, kids?
Yeah.
I know it's Monday morning, but this is exciting stuff for me. I love this stuff. Okay, you ready, kids? So what are we going to say? Say it pulls the, what are those things called again, kids? Pulls branches away from the what? Whoop! Can't spell. Can't spell. CP, you understand why I have problems writing letters of recommendation? I never finished my story, did I? So when I was in high school, I really struggled in English and writing and stuff and speech. And it was so bad, I got into UNI, but in order to be a teacher, because I really wanted to be a teacher, so I could see smiling faces like yours on Monday mornings every day in math class. In order to be a teacher, I had to take remedial stuff back in college at UNI. And I don't know if any of you were like me, but when I was in high school, I could read books. I could read it. I couldn't tell you what was in it because my mind was... How many of you have read something, like read 10 pages, like my mind was somewhere else? I have no idea what I just read. That's me. And you know what? That was always me. And man, I struggled with that. I struggled. I was always scared to give speeches in front of classes. Always timid, quiet. Look at me now.
Wow.
Trust me, when you get older, they say you settle down. I don't believe that. I think the older you get, the crazier you get.
Oh, definitely.
So look out, Sam. It's going to get wild. You might need to start cheering at NASCAR races and get that crazy. What was the other thing we said instead of pulling away from the origin, kids? Could be a vertical stretch by what scale factor? By the way, people in North Carolina, if you use this lesson, hello.
They're not always screaming.
It's all good. I don't care. I just wish they would do it enough so I can start getting paid.
What does the teacher do when you switch classes, though? They just screech.
They're always there. Once it's in the channel, it's theirs. I don't know what they do. I'd like to go and find out. Hey, questions on this page. You understand the shape of the hyperbola, first of all. If I change the effect of 6 up here, kids, it's just really a... What if I said maybe this is like 1/2 over x? The vertical shrink, yep. All right, let's move. Next page, let's talk. Page 3 is very important. This core concept is a biggie today, okay? Oh my gosh, and I'm not even going to show it to you, am I? That's not cool. All right, kiddos, here's the deal. Core concept today. You're going to start looking at core concepts of the form y equals a over x minus what? Plus k. There's a lot of steps that you need to follow. Okay, so the first things you're going to do, draw the asymptotes at x equal what? And y equals k. Step 2, plot points to the left and to the right of the vertical asymptote. Step 3, draw the 2 branches of the hyperbola so that they pass through the plotted points and approach the asymptote. Let me give you an idea of what's going on here in the graph, okay? I'm going to kind of change my highlight to be a different size here so I can see my graph a little better. But it says, draw asymptotes where and where first. Okay, let's just pretend x minus h was like x minus 3 in the denominator there, x minus 3. What value don't you want x to be if you have x minus 3 in the denominator? 0. You don't want the denominator to be 0, so what number minus 3 would make that whole denominator 0? 3 would. You would have what's called a vertical. So whatever this h value is, if it says minus h, you go to the positive h. Okay? If this would say like x plus 6, then you would go to not positive 6, but... Okay, so what's going on here? They're going to tell you, you need to draw a vertical asymptote somewhere. They're calling that variable what?
H.
Okay, so it might look like this. You might have a vertical asymptote right here, okay? And that vertical asymptote is my h value. That's not very vertical, is it? All right, there we go. And then it says, draw your other asymptote at y equals what? This might, k might move up, it might move down. But it's a plus k value. So if this is like plus 6, where would the horizontal asymptote be? Well, it would be at 6. Okay, so let me just draw a, this might be right here. I don't know. But the horizontal asymptote is going to be k right here. And now what's going to happen, kids, is if you look at that 1 over x, if you looked at that graph 1 over x, can I go back to 1 over x? In this graph right here, kids, what were my asymptotes? Okay. Isn't this 1 over x really the same as 1 over x minus 0 plus 0 out here, kids? So the h value is what? Horizontal asymptote at 0. The k value is 0. Vertical asymptote at 0. Okay? So let's look at what's going on here. When you get your asymptotes like this, you're either going to have a graph in there that looks like this and this with it, or it's probably going to look like, I know it's not the best sketch in the world, this and this. Okay? All we're doing is saying the asymptotes aren't the x and y axis anymore. We're just moving it. That's all we're doing is translating stuff. So in number 2, they say, hey, graph of what? Translation of a rational function. Negative 2 over x minus 3 plus what? Okay, check this out, kiddos. This is of the form a over x minus h plus k. So the x minus h part right here, what is the h value, kids? So, at 3 we're going to have a, what kind of line? Vertical line, called a vertical asymptote. There are no values on that vertical asymptote, which is a vertical line at 3. So on your graph, draw your vertical asymptote. Do it now. Oh, asymptote. If you don't do it now, I'll kick your functional asymptote. They know I'm crazy, okay? But you know what? People in North Carolina are probably crazier than I am.
Oh, yeah, definitely. I've never been there.
But they've got really good basketball teams in North Carolina. Duke, North Carolina. Heck, NC State's good this year. Braden, help me. Who else plays basketball in North Carolina?
North Carolina.
What's the K value in this, kids? So, here's the deal. I draw my other asymptote at y equals what here? I screwed that up big time. There we go. Gosh dang it. Did your dad watch the race, Sam?
Yeah.
Was he happy with the outcome?
I don't really know. He's the one that told me all the things.
Did he?
So I didn't watch it.
Okay, so your asymptotes, guys, first of all, is this a value positive or negative up here? Okay, so state the domain and range. Well, let's do that. We'll get a graph here in a second. Let's do the domain. Domain is all x's except for what? Okay, so I'm going to write this down. All reals such that x can't equal what value here, kids?
3.
X cannot equal 3. That's your domain. Why not 3? Well, if I plug 3 in right here for x, kids, what's that make the denominator? 0. Okay, and then when I graph the hyperbola, it gets really close to this k value. What's your range going to be, kids?
Same thing.
Yeah, you have an asymptote right here at 3, so the range is going to be the same. It's all real such that, what?
X and y doesn't equal 3.
You bet. All real such that x not equal to 3.
Would it be y?
Oh, yep, good catch. Thank you. Y cannot equal 3. Very good. Nice job. Thanks for saving me again. How you feel about that, kids?
There are.
You understand how to move the asymptotes away from the x and y axis? What if this would have said x plus 5 down here? Where would your vertical asymptote have gone? -5, okay? So it's kind of the opposite of this value, but the same as this one up here. All right? Let me jump into decimals with this quickly. Kids, what was the function again?
G of x.
-2
Yeah.
divided by,
X minus 3.
okay, so does it look like there might be a vertical asymptote right here at 3? And then when I put that plus 3 on the outside here, this is going to shift everything up 3. So this plus 3 right here, this x minus 3, kids, think about this. X minus 3 in parentheses, anything in a minus, does that have an effect for translating stuff left and right? What's a minus 3 do to everything when you're inside of parentheses? Moves everything to the right. It's kind of the opposite. Now think about adding a constant on the bottom. Adding a constant at the end there moves it up or... So isn't my horizontal asymptote at 0 right now?
Yeah.
But if I take and add 3, what's it going to do to everything in the graph? Moves it up 3. Okay, that's where that asymptote lies. Okay, now why does it go this way? Like if I let me put the asymptotes in there. What were our asymptotes? X equals 3, was that right? And y equals 3. Oh, Shaw did. There we go. Why are we, if you could divide your asymptotes into like quadrants, 1, 2, 3, and 4, why do my graphs land in quadrant 2 and 4? Because the A value was negative. Okay, so let's get back to our graph. It doesn't need to be perfect. We've got the asymptotes in there. Going to look kind of like this now.
No.
Oh, I got that wrong, didn't I? Good. Oh, shoot. I'm just pushing buttons up here. That's all I'm doing. Oh, where should it go?
The second.
Let's put 2 in. What would 2 get us right here? 2 minus 3 is what, kids?
Negative 1.
-1. So what's -2 divided by -1? Positive 2. So this should be at... Kids, how many units, when I go 1 unit to the left or right of this, how many units above this is that point? How many units above the horizontal asymptote am I? How about if this -2 was maybe a -9? Be way up there, wouldn't you? Okay. So a way to do it is this. Say, okay, 1 over 2, 2, and then just sketch it, okay? I don't care what it looks like. Hit these points, though. Kind of comes up here. Takes off that way, comes down here, takes off that way. What do you think? Do you understand the A over X minus H plus K form? What's the H established for you? It establishes the X that we can't have, or the vertical, asymptote. I didn't hear what you said, Haley. What did you say?
S-curve.
Yeah, that word. What's the K form? The Y asymptote, right? You guys okay? I was practicing my Obi-Wan Kenobi. How's it going? Any good?
Great. Spectacular.
I want a ruler that's a lightsaber ruler. If I get a lightsaber ruler from somebody or meter stick, I'll dress up as Darth Vader and teach for a day.
You give them an A.
What's that?
Just give them an A if not doing that.
Might do that. I'll even get the funny voice and everything, and I'll breathe funny.
Is there even such thing?
I don't know. I bet there is.
I know it.
Now you know what I'm going to do in my prep hour? I'm going Google searching.
I bet they sell one.
I'll bet you're right. Okay. Hey, let's start looking at example 3. Example 3, things are going to get more complex. Okay? It says, how do you graph a rational function of the form y equals, I don't just have a up here, do I? And I don't just have x minus h down here, and I don't have just plus k here. So how do I do that? Okay, so here's how this works. Okay? We know how to move asymptotes around that are vertical and horizontal from the x and y axis when I can get it into what form, kids? This is a nice form because h establishes the vertical, right? And doesn't k establish my... Okay. Let's talk real quickly. How do you do this? Oh my Lord. Okay, I'm going to put some work over here on the left. Graphing a rational function of the form y equals ax plus b. So in this case right here, what's the a value in this function we're about to work with? What's the b value? Okay, what's the c value down here really? And what's the d value? Okay, let's talk, kids. This is not very easy, right? It's not easy because I don't have just a number up top here. We need a number up top here to make this work. So here's what we're going to do. I'm going to move my work over here to the left. I think you should do the same thing. What I'm going to write over here on the left and get into your notes. All right? You ready, kids? Ready? Okay. What we have to do is take that 3x minus 1 and divide it by x plus 2. Now, a couple different ways to do this, but I'm going to do the long division way with this, all right? You need to look at your leading parts of this all the time. All right, help me out, kids. How many times will this 1x go into the 3x? Okay, help me. Now we got to take 3 times this whole x plus 2 when we do rules of division. Do you understand this 1x goes into 3x 3 whole times? Does everybody get that part? Okay, we got to take 3 times this whole mess now here. So what's 3 times x plus 2, kids? Okay, now we need to take this by rules of division and do what? Subtract. Okay, well what do the 3x's do? Now when you get down to a whole number for a remainder, this is good. What's negative 1 really minus 6? Negative 7. Okay? So what this ends up being, kids, is the following. This is the same as 3. I got a whole quotient of 3, remainder what? Okay, but this 3 is really 3 over what value? Minus how much for a remainder? Those two functions right here. Let me show you something. Let me show you something. How did the function start out there, kids? What over what? So up top you had 3x minus 1, is that right? Whoops. Over something doesn't seem right here. this? What did I miss? -2. So it look like there might be an asymptote at -2 here, kids. But I'm not seeing a -7, are you?
Where are you seeing?
The asymptote should be at 3 here, right? Do you agree with that? Duh. I got it. I'm so goofy. I can't even do things right today. I'm sorry. I made a total big mistake there. We don't do long division enough, by the way. I'm just going to state that as the obvious, okay? I'm sorry. I screwed this up. I have everything correct here. Our answer should be 3, remainder what, kids? Okay, so it would be 3. But if I was going to put this in like negative, if this was like -7 and this is 12 right here, wouldn't you call that 3 and -7 twelfths or something like that? Okay, so isn't this really 3 the whole times it goes in there plus -7? Okay, here. 13 divided by 4. How many times will 4 go in there? 3 would be 3 1/4, right? I just put the 3 over the wrong part. The -7 should have gone over what, kids? So this should have been 3 minus 7 over, this was my remainder. This is what goes over that, not this. Duh. You guys agree? Okay, listen to me on this right here. So when we divide this out, this becomes really the same as, I'm going to write it this way. Watch how I write this. -7 over what? -7 over x plus 2 plus what value? Okay, that looks better to me. Let me do something here quickly with decimals. When we divide this out, okay, so what I'm going to write down here is this. We need to divide this to the form a over x minus h plus k. All right, so where's your horizontal asymptote going to lie? At what value? The vertical one would be at, not +2, but -2. Okay, so let's just check my graph on this. If I put in x equals -2, does it look like I might get an asymptote between those if I keep zooming out, kids? That looks pretty much right, doesn't it? Okay, where is the horizontal asymptote going to lie? Does that look like the right one? Okay, and we got that by dividing it and turning this into 3 is the constant out here, plus the remainder -7 over x plus 2. And when we get to this form, you know that your domain is all reals except x cannot equal what? -2. Okay, the range is all reals, but where was our horizontal asymptote here, kids? +3. The range is all reals, but y cannot equal what value? Oh boy. Kids, I would encourage you, star this. I'm not going to get too picky about graphs because you have what tool to help you with graphs. And then you should be able to get some decent sketches from that.
Wait, so how did you get +3 on the side to turn into a positive versus negative? Is that just k is +2 or?
Okay, so here's x went into 3x 3 times, right?
Right.
Okay, so what we do is say we've got 3 whole values up here of this going in here. That's this part right here. And then our remainder was, so to write this in like mixed number form, this would be like 3 plus the negative 7 over x plus 2. So all I did was flip the order on this. This is really negative 7 over x plus 2. What kind of 3 is this really up front here? So I just moved the positive 3 to the back.
Oh, okay.
Makes sense. So we could obtain that form.
Yep.
Okay. Kids, I think that's a great place to stop today. I'm going to go ahead and stop that.